All right, you guys, I'm going to do a quick video of 4.1 part 2 for cohort B since I was on mute. Sorry about that. I had to go from geometry to pre-calculus, geometry to pre-calculus, pre-calculus to geometry, give notes, you know, the people here and the people at home, and it was a lot to get all my settings straight. And for you guys, you know, the only mistake I made all day was that you guys are on mute, so I feel pretty lucky about that, but unfortunately you couldn't hear it. So let's fix that by me doing this. I want to start here from the notes and look at this leading term right here. MathXL is calling this a power function, and that power function is going to dictate the end behavior. So you go to this leading term. I just wanted to clear this up so that when you're in MathXL and they ask about a power function, you know what that is. Okay, so that's right there. That's the power function. And as we go to infinity, you know, when we go to a billion to the right or to the left, so this would be a billion to the left, this is going to take over because of the exponent of 3. If we go a billion to the right, this is going to take over, and this is going to cease to matter. And so the end behavior will act just like a regular y equal to x, which would be down to the left and up to the right. You know, here as we go left a billion, this term is going to take over because of the exponent of 8, and this term will take over because of the exponent of 8. And so this will act like a down-down parabola because it's negative and even. So this will, you know, none of this will cease to matter as you go to infinity, and this would be, you know, down and down. So just to clear that up with MathXL. Okay, so multiplicity is the word that we're going to start with, and this is the number of times the same number is a root or a 0. Those mean the same thing. That's just a solution, you guys. Also an x-intercept. You can use any of those terms and it means the same thing. All right, so if we were to graph this with transformations, this is your parabola shifted right 3. It would go through at 9, 3, something like this. And you know, you would see that x equal to 3 is an intercept. That means it's a solution. However, if you were solving, you know, you y0 set to 0, equals 3. So it has a multiplicity of 2. We call this a double root. So anytime you have a square, you're going to be able to account for 2 solutions. Granted, 3 is the only solution, but in order to account for that exponent of 2, you see that it happens. It has a multiplicity of 2. It's called a double root. Same thing here. This is going to be our cubic function that goes through at 3 because it's shifted right through. Same thing with transformations. If you were to solve it out just like this, you'd get x minus 3 minus 3x minus 3. So 3 is indeed a solution, and it's called a triple root. It has a multiplicity 3. And then this last one here graphs out like a wider parabola. There is 3. And this time x is equal to 3 again if you were to expand it out, and it has a multiplicity of 4. So at exponent of 4, you'll be able to account for 4 zeros. Even if they're the same, they'll just have a multiplicity. So to summarize, c is a root, so that's negative c, so positive c is a root. If this were positive c, negative c would be a root. So it's a root, a 0, a solution, what have you, and it has a multiplicity of the exponent. If it is even multiplicity, it is going to touch the x-axis. This is going to be important when we try to graph without our graphing calculator. If it has odd, note that it crosses. All right, so if it has an even multiplicity, it touches. If it has an odd, it crosses. Okay, so we're going to try to graph this one here without using our graphing calculator, but just all of our knowledge. So this is going to lead us through what we need to do here, and MathXL will lead you through in the same type way. All right, so find the zeros. Just set each one of these equal to 0. So x minus 5 equal to 0 would be x equal to 5. This would be x equal to 3, and this would be x equal to x plus 1 equal to 0 would be x equal to negative 1. So this has multiplicity of 1. That's odd. That's going to just cross. This has multiplicity of 2, so this is going to touch. And this has multiplicity of 3, so it is going to cross. All right, so great. At 5, I know, is that 4? make it 5, 3, 5, -1. Okay, so I've got those zeros. The graph has to go through those points, and it's going to cross, touch, cross. Okay, what's the y-intercept? We're just going to zero out x. So plug in 0. You end up with 0 minus 5, 0 minus 3 quantity squared, and 0 plus 1 cubed. And so that just comes out to -5 times 9, which is -45. So we'll just throw that down here, -45. So we got to go through this point too, because that's the y-intercept. Now let's do our end behavior. So I don't want to FOIL x minus 5, x minus 2 squared, x plus 1 cubed. That sounds terrible. We don't want to FOIL that. So we just want to see what the leading term would be. And we need to look at the a value, because if it's positive, it's going to do something different than if it's negative. Well, in this case, we have a is equal to 1. So note that in this one. You don't really have to do anything because 1 is neutral with multiplication, but if there were a value there, you'd for sure have to consider it. All right, so leading term is going to be the x and the x squared and the x cubed. So what would be the leading term? It would be x times x squared times x cubed. So it would be 1, 2, 3, 4, 5, 6, x to the 6. So this is going to behave like a parabola, y equal to x squared. It will do the same thing as y equal to x squared, which is up, up. So as we go left, we go up. As we go right, we go up. All right, so make a sketch. Well, I know I got to be going up, and I know I got to be going up. I know I have to cross, I know I have to touch, and I know I have to cross, and I have to hit this point. So this is going to be very vague right here in pre-calculus. You're not going to know what happens here. And as you touch 3, as you go up and touch 3, you're not going to know what happens here so much either, like how far down does it go, or when does it make its turn back. And that's okay. You're not supposed to know that until you get to calculus. Calculus is what will identify those points. So we're just going to go down. Let me try to get it where it's going to hit that one. So we're going to cross. Don't know how far down we'll go. We'll just make it vague. We're going to go across that y-intercept, touch, go down, I don't know, and turn it back up. All right, if you graph this on your TI, you would see that this actually goes lower, but I'm just, reiterating that you don't know how low this goes, and you don't know how low this goes either. It's just something for next year. What I would be checking is cross, 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 up, up, and this y-intercept. All right, so that is an approximate graph. Okay, so next page, a little bit of review here. So we saw that a polynomial of degree n has at most n zeros. So what does this mean? If you have x squared plus 5x plus 6, something like that, you're at most going to get 2 solutions here. You may get 1, you may get none, but you're never going to get 3 solutions with a parabola. It can only cross the x-axis twice, not 3 times. So the maximum number of solutions you'll get is going to be the same as the degree. And then turning points is one less. That's max or mins. That is turning points or U-turns. Okay? And then changes in concavity is 1 less than the turning points, which is 2 less than the degree, so that's n minus 2. That's where we have a change in concavity. Okay, so this is a chart just to look at. Again, positive evens, long-term go up, up. Negative evens go long-term down, down. Positive odds go down to the left, up to the right, and negative odds go up to the left and down to the right. All right, so prompt you'll get in Math Excel is the following. The following is a complete graph of this polynomial function. Is it even or odd? Well, it goes down, down. It goes down, down. That's the same, so this is going to be even because the end behavior is the same. Okay, is it positive, negative? It's going to be negative because it's down, down. Okay, the zeros, there's a 0, there's a 0, and there's a 0. So we have a touch, cross, cross. The real zeros are x equal to 2, x equal to 0, and x equal to, let's put negative 2 there. Let's go in order. Negative 2, 0, and 2. So this is a cross. So it's going to, this is a touch. Sorry, I'm trying to hurry. This is a touch. So this is going to be an even multiplicity. So we want to keep that in mind. So what's the smallest possible degree of f of x? Okay, well, first of all, I know it's got to be negative because it's down, down. So I'm going to, even though it didn't ask for this. I'm going to put that in there just so you can see it. And let's put in x plus 2. Okay, so this negative 2 goes in at x plus 2, and that's even, so this might be 2, 4, 6, 8, 10, etc., but it said smallest, so I'm going to put a 2. And then x minus 0, which is just x, and that's crossing, that's odd, so smallest possible is here. And then x minus 2 for this guy right here, and that's crossing, so that's got to be odd, and the smallest possible there is 1. All right, so you put this into Math Excel, and you say, okay, this is of degree 4, because that would be x squared, that would be x, that would be x, and you get it wrong in Math Excel, and you're super frustrated. So what I failed to look at here are the turning points. So this is a max, that's a turning point. It goes from increasing to decreasing. There's a minimum, there's a maximum. This is a minimum, that's like a valley. This is like a peak. So if you notice, there are 5 turning points. Okay, so up here says if you have a degree of n, then you're going to have 1 less turning points. So if I have 5 turning points, that had to come from a degree of 6. So that bumps this up to being a 4, and that's how we get 4, 5, and 6. So this is degree 6. Okay, now 5 and 6, we just put Humpty Dumpty back together again. So f of x here, it's degree 3, and we have 1, 2, 3, 0, so that's super easy. You like a problem like this. We're just going to go x minus 1, x plus 3, and x minus 5. Okay, it did not give me a point that it goes through, so I'm just going to let my a value be 1 here. Why not? It didn't tell me, it didn't lock it down to a point, so this is just, the easiest polynomial that I can write with those degrees. Okay, so let's FOIL x squared plus 2x minus 3 and x minus 5. It did say factored form, which is here, and now expanded. X cubed minus 5x squared plus 2x squared minus 10x minus 3x plus 15. And so we end up with what? X cubed minus 3x squared minus 13x plus 15. There's expanded form, and we're done there. All right, the next one says degree 3, so I need to account for 3 zeros. So there's 1, 2, but it did tell me multiplicity of 2, so that accounts for it. 1, 2, 3. And this says just to leave it in factored form, so this is easy. X minus 1, and then x plus 3 quantity squared. So what the last question here, what do all of these equations have that we are ignoring? They might have an a value other than a equal to 1. Okay, and so how would I know this? It would be if they gave me some point that it went through, and then you'd have to plug in the x value and the y value, and you'd have to have a right here, right? You'd have to put a there, and you'd have to solve it out and get a equals, and then put that a value back here. You had to do that on the test, but these here simply just are assuming the a values is 1, but just look out for that in the future. Okay, so there we go, back on track, period 5, cohort B, and we'll see you guys in class. Talk to you soon. Bye.